Welcome to chapter 13.1. We are going to talk about mirrors in this section. We are going to talk about convex mirrors, concave mirrors, what kind of images they produce, and then talk about the different types of rays that are going to come out of the original image or original object to create either a virtual or real image. So let's get started. So the first thing that I want you guys to know, basic facts, is that the only reason we are able to see an object is because of light from a light source that is reflecting off of that object so that our eyes can perceive it. So when it's darker, obviously it is harder to see an actual light, or it's harder to see an actual object because there's not enough light. So if you're at home and you're sleeping at night, some people like to have pitch dark room. And the only thing you might have is a alarm clock or a digital clock. And the only way that you can kind of make your way around the room when all the lights are turned off is by the dim light that's being reflected off of objects from the alarm clock. But if you have a night light, you're able to see a little bit more because you have more light coming from that light source that can hit different objects in the room so that you can actually see it and hopefully not trip on things if you're going to the bathroom in the middle of the night. So the process of how this works is you have a light source, it's going to hit an object, and then that object is going to have light reflected off of it into your eyes, and therefore you will see that object. Light can also reflect off more than once. So we're going to talk about how the light source expels light waves in all over and in all directions. So when it gets reflected off an object, it's also going to go in all directions. But the way that our brain perceives it's going to be a little bit different. So light rays from a light source, like I said, are going to go in all directions, right? Like a ripple in a water. If you throw a pebble into the water, that water is going to make a bunch of ripples. It's going to keep going on and on and on. Same thing when you turn on a light bulb or a light source. So if I go into my kitchen and I flip on the switch, the light comes on. The light rays from that light are going everywhere, right? So even though they're going everywhere, if I look at just one single ray of light, they're going to actually be traveling in narrow beams, okay? And those narrow beams are going to travel in a straight line. So if I have a bulb, it's going to have multiple light rays that are all going to be traveling in narrow beams, and each narrow beam is going to be traveling in a straight line. And this is called light rays, okay? So the light ray is the narrow beam and is traveling in a straight line. So there are many light rays that come from one light source. And these light rays can change direction when they're being reflected. So if I turn on my kitchen light, I have a pot on the stove. The light rays that are going to hit the stove, the pot on the stove, is going to be reflected off in a bunch of directions. But when my brain looks at it, I'm not going to see all that bunch of reflections. I'm just going to see the entire pot as a whole. If you've ever studied Greek mythology, or maybe you've looked at it in English class, there's somebody named Narcissus that they refer to in Greek mythology. And basically it's this guy who was looking at a pond and he happened to see his reflection and he was like, wow, that's a good looking dude. And he fell in love with it, right? But that was his own image. He fell in love with himself. But if we look at it in a physical science perspective and pertain it to the chapter that we're on right now, how was he able to see his reflection so well that he was able to literally fall in love with it, right? And that's because the pool of water that he was looking at that showed his reflection was similar to a plane mirror. So what is a plane mirror? A plane mirror is a flat, smooth mirror. So like a pool of water, still water, has to be still water. A store window. All of these are examples of what a plane mirror is. And in a plane mirror, you can see your reflection very clearly. So reflections from a plane mirror are going to have some characteristics. They are going to be upright. That means that if you're standing up and you look in a mirror, you're going to look standing up and not like you're on your head. If you're 1 meter from the mirror, it's going to look like your image is also 1 meter from the mirror. So if you look in a bathroom mirror and you see there's a sink, between you and the mirror, it's going to look like there's still a sink between you and the mirror in your reflection, not like the sink all of a sudden disappeared or something. But the distance, you're gonna see the distance. So if you're 1 meter from the mirror, your reflection's gonna look like it's 1 meter from the mirror as well. If you're 2 meters from the mirror, your reflection's gonna look like it's 2 meters from the mirror, so on and so forth. But if you have a shirt that has writing on it, it actually looks backwards, and that's because of the way that the mirror is reflected off of the mirror. So let's talk about virtual images. So when you have light waves that are being reflected off of you, they're gonna travel in all directions, right? So I said light from a light source, the light rays are gonna come, hit an object, and even as they're reflected back, they're gonna travel in all directions. So if I have a light that's gonna hit my nose, it's gonna be reflected off of my nose, and it's gonna hit the mirror in all different directions. Some of these light rays are actually going to hit the mirror at an exactly right angle or right way that it's going to get reflected into my eyes, therefore I can perceive, hey, I have a nose. Now, your brain, like I said, is not going to interpret all of the different light waves that are being reflected in all different directions. It's only going to see it as if it's coming from one light ray. So you're going to see your nose as if it's going to come from one light ray and not a bunch of them, and that they're coming in a straight line and not in various directions. An image that your brain can see, your brain can pretty much see an image even though there are no light rays that has hit that image's location. And that's how we get the title virtual image, right? So that image isn't technically, you're not getting light rays that are hitting that image in every single spot, but your brain is able to kind of put it together. And so your virtual images are made by rays of light that don't actually come from where the image seems to be. So if I put a piece of paper where I think that the virtual image is going to be, it's not going to be on that paper, okay? You're not going to have an image on that paper. Versus real image, when you do put a piece of paper where you feel like that, where you think that image is going to be, you can actually see a projection of it. So in a plane mirror, like a virtual image, a plane mirror is like a virtual image in that they're both going to be having an image some distance behind the mirror. Okay, so let's talk about concave mirrors. So concave mirrors are basically a mirror that has a surface that is curved inward, okay? So the surface curves inward. Now this is the way that I remember concave from convex, is that look at the word cave, right? If you see a cave, usually you go into the cave, right? So when you have a concave mirror, it's gonna look bent like a cave's entrance. So you can kind of put it together for a way to remember. Unlike plane mirrors, the concave mirrors are going to reflect light waves to form an image, except their images are going to look a little bit different than a plane mirror would because of that curve that it has. So features of a concave mirror. There are a couple features that I want you guys to know. It's super important. One is that a concave mirror has a optical axis. What is an optical axis? Basically, an optical axis is an imaginary line that is super straight, and it's drawn perpendicular to the center of the surface of the mirror. So if I decipher this, here's my center of the concave mirror, and I'm gonna have an imaginary line that's gonna travel to the center of the mirror, and it's gonna travel in a perpendicular way. Remember, parallel is like this, when they're both distance apart from each other, is traveling the same line. Perpendicular kind of looks like this, like an intersection, okay? So you can tell that this optical axis is making this perpendicular line because this would be the optical axis, and then this would be the mirror. Another feature that a concave mirror has is something called a focal point. Now this point is going to basically be located right in the middle of the optical axis. So basically it's a point at which the once parallel light ray is going to hit the concave mirror is now reflecting back in various directions, but it hits at one point on the optical axis. So technically the focal point is not always in the middle of it. In this case it is, but it can be in different points on the optical axis. The main thing is usually when rays are being reflected off the mirror, they're going to travel through the focal point. So for example, if I have this light ray coming in, it's going to be reflected right through the focal point. If I have another light ray coming in, it's going to be reflected through the focal point. If I have another light ray coming in down here, it's going to be reflected through the focal point, so on and so forth, okay? And then we have something called focal length. Kind of, you can tell by the words in it. It's the distance from the center of the mirror to the focal point. So I have the focal point here, I have the center of the mirror here. So the focal length is simply the distance that I have between the focal point and the center of the mirror. So let's talk about ray tracing for concave mirrors. So basically I'm gonna show you two different rays, and we're gonna see how when the light is being reflected off an actual object, what's gonna happen. So in this specific case, if the distance between a candle, an actual object, and the mirror, which is going to be the concave mirror, is greater than the focal length, then this is what's gonna happen. So let's see what happens. So bear with me as I draw my candle. So this is my wonderful candle over here, okay? So I have a candle right here. All right, so let's give it a little foot stand. And then I'm gonna draw my optical axis. And then I'm gonna draw my mirror, all right? So remember, this is a concave mirror. Okay, so if this candle that I just drew was my actual image, I have my optical axis right here. Where would my focal point be? So my focal point would be right in the middle. On my optical axis. Now, remember how I said that for a ray tracing for this specific purpose, the distance between the candle, which is right here, and the mirror, which is right here, has to be greater than the focal point to the mirror. And it is. The candle is way further out than the focal point is from the mirror. So we're good. So in this case, what would happen is if I take one ray, let's call this ray A, and I'm going to draw it coming from the flame of my candle. And let's do a different color. I'm going to draw it from the flame of my candle, and it's going to go through my focal point, and it's going to hit my concave mirror. Once it hits a mirror, like any mirror, it's going to be reflected, and it's going to come over here. All right, so this is going to be ray A. Now, if I take another ray of light, and it's going to come also from the flame, it's going to come over here. Now, this ray is going to come out of the original candle, the actual object, and it's going to go parallel to the optical axis. So you can see how this ray B is parallel with this optical axis, right? So now it's going to get reflected, but when it gets reflected, it's also going to go through, oops, let's do a better job of that. It's going to go through the focal point, and it's going to hit right here. Now, ray B is parallel initially to the optical axis, and when it gets reflected, it's going to go through the focal point. Ray A is going to go through the focal point initially, and when that gets reflected, it's actually going to go parallel to the optical axis. So this ray right here, even though I didn't do a good job of drawing it, is going to be parallel to the optical axis, okay? So now, where these 2 points meet, I'm going to be having, let's do a better job of that. I'm going to have a flame. Okay, because it's going to be looking like the candle that the original object was. So they're going to both meet, both of the reflected rays from ray A and B are going to meet at now a newly formed image of a candle, and they're going to meet at the flame because they were reflected from the flame, okay? So they're going to meet at the flame because they were reflected from the flame, and this is going to create a real image. So basically what's happening here is that ray A is going to start from the flame. It's going to pass through the focal point, and it's going to be reflected off of the mirror and going to hit onto a flame, the image of a flame, okay? This is a real image of a flame. Ray B is going to start from the flame of the actual candle as well. It's going to travel parallel to the optical axis, hit the mirror, the concave mirror, and as it gets reflected, it's going to go through the focal point and also hit the real image's flame. So now the real image, which is down here, this is a real image, is now inverted, which means it's upside down, and it's being created by this concave mirror, okay? After Ray A and Ray B are reflected by the mirror, they are going to intersect on the reflected image, which is now this inverted image. Okay, so let's talk about a real image for a second. So what is a real image? We just talked about a virtual image. Now what's a real image? A real image is basically an image that is formed when light is converted to form an image. So this is when, if, like I said, for a virtual image, if I put a piece of paper to where the lines of the rays are coming together, you will not actually see the picture on that paper. But with a real image, you can see a projection of it. So if you hold a paper, like I just pretty much said, if I have a projector or like a wall or something, I can see that image coming together. So let's talk about spotlights. When I have an object that is placed at the focal point, the mirror reflects all light parallel to the optical lens. So the light rays in the spotlights are never going to meet, and then no image is actually forming. But this is happening when I have an object placed right at the focal point, and all the light that's going to be reflected is going to be parallel to the optical lens. So in this image, I have my light bulb right in the middle, and you can see that my focal point is right here. You can see that I have this little light bulb right in the middle. And as the light rays are coming from this light bulb, it's hitting the mirror and it's traveling back parallel to the optical axis, right? So this is the optical axis, and all of my light rays, so this light ray is going in, hitting the mirror, and it's traveling parallel to the optical lens. This light ray is coming in, hitting the mirror, and traveling back out at an optical lens. Same thing, coming in, traveling back out at an optical, and parallel to the optical lens. So this is what a spotlight is. The rays are never going to meet. So see how these rays that are coming out, they're never meeting. They're just going to keep going. And you're having no image that is actually being formed. So you're not having a reflection of this light bulb in the middle. You're not seeing anything at all. So mirrors that magnify. Concave mirrors magnify an object you place between the concave mirror and the mirror's focal point. So remember, concave mirror is a mirror that looks bent like this. So they're going to magnify any object. So if I have my focal length right here, and this is, my optical axis is right here, and this is my focal point right here. If I have an image right here, the concave mirror is going to magnify this object. So it's going to make it look bigger, okay? So I would have like a bigger looking person here. So they're going to form a virtual image, and your brain is going to act like the concave mirror is a plane mirror, so that your brain interprets diverging rays, which means rays that are going apart, as if they're actually coming from one point behind the mirror. I'm going to draw this out so you're going to be able to see it and understand it, but I just wanted to explain it in words before we get to that point. So behind the mirror, you're going to have pretend virtual rays that are pretty much going to create this virtual image. And then the image is also going to come out upright. That means it's standing up, not upside down. And mirrors that we use are like makeup mirrors or shaving mirrors, right? So when you have a makeup mirror for girls, if you look closely, you can kind of see all of your little blemishes that you have. Or if you have a shaving mirror and you look closely, all of those little pores that you have are now magnified, so you can see if you miss a spot or something. So let's draw this out, okay? So if I have a concave mirror right here, this is my concave mirror, okay? Mirror, my concave. And I have my optical axis that's going to come right in the middle, right? So this is my optical axis. I have my focal point right here. Now say that I have an object right here. So say that I have this little plant. Okay. What's gonna happen is that I'm gonna have light that's gonna come from this plant. It's gonna hit this wall, or sorry, this mirror, and it's gonna be reflected back through the focal point. Okay? Now, if I have another ray, it's gonna come out, hit the mirror, and it's going to be reflected. All right? So notice how the ray, this ray, say this is ray B, and say this is ray A. See how ray B has not gone through the focal point, okay? But now what's gonna happen is this ray A is gonna kind of create a virtual ray behind the mirror, as well as ray B, okay? So now, as they create this virtual image, what's gonna happen is you're going to get a plant. But this plant obviously looks a lot bigger than the original plant. So this is your virtual image. Okay? And then these two rays, this ray and this ray, are your virtual rays. And you can see that your eyes are going to see this rays as if they're coming, these rays as if they're coming from one point and not two, okay? So these two rays are diverging, right? But your brain is going to interpret it as if they're not diverging, as if they're coming from one single point. Let's talk about convex mirrors. So convex mirrors are different than concave in that they're going to be curved outward. So they're gonna go look like this, okay? So if you ever seen the side view mirrors on like a school bus, they have these convex mirrors because they, that's how it helps them to see further out. If you look, if you're going down the grocery aisle, at the end of grocery aisles, you'll see these convex mirrors, and that way they can kind of see more. Even though it looks smaller, they can see more down the aisle and more detail from the environment. So when light rays hit convex mirrors, they actually spread apart more after they're reflected. These reflected rays, they don't actually meet, so that the image created by the convex mirrors are also called virtual images. So let's take a look here. I have my convex mirror in blue, okay? And so you can see it right here. This is my convex mirror right here, okay? And I have my candle. This is my original object, I should say. Okay, so this is my original object. And from this original object, I'm having one light ray come out, which is going to be light ray A. It's gonna hit the mirror, be reflected out, but it's going to create virtual rays on the back of it. Same thing with ray B. I have a ray coming out, it's going to be reflected by the mirror, but I'm going to have virtual rays behind the mirror. And this is going to create an object that's virtual image, so that means it's upright, but it's going to look smaller. So remember how this image looks a lot smaller than it did when I used a concave mirror, which magnified that image, so magnified that green plant that I had. But now with a convex mirror, it's pretty much shrinking it, it's making it a lot smaller. Okay? So uses of convex mirrors. Like I said, it gives you a wide, oh, this is supposed to say wide, not wild. It gives you a wide field of view. So that's why if you look on the rear view mirrors of like the buses, they're able to see a lot more rather than up close. And usually side view mirrors, rear view mirrors are made from this, and they can look, and they usually say, you know, objects appear a lot closer than they look because of the way that the mirror is designed. Even in grocery stores, like I said, they have them at the end of the aisle. So if someone, you know, they say, hey, there's a spill, they can look directly at that mirror if they can't see all the way down the aisle and usually be able to see it. And they have it in factories. Factories are huge. So you need these kind of mirrors so that they can kind of condense all of that into a smaller image so that you can see more. So mirror images. Concave mirrors are the only mirrors that magnify images, okay? So concave mirrors, they magnify the images. Convex mirrors, they make the objects appear smaller and further away. So this is when you have the little, if you look on your car side view mirrors, you can see that it says objects are closer than they appear because of the way that the mirror is made up. Same thing with makeup and shaving mirrors. They take your face and they completely magnify it so you can see everything a lot clearer because of the way that they're made up. When we talk about real images, this is when the rays are converging, so they come together. The light rays actually intersect, and you can see an image on a screen or a projection, and that image is inverted. So a lot of times, if you look at movie theaters and you look all the way back at the projection, it actually looks like the movie on the projection thing is like upside down, but they flip it when you actually see it on the big screen. And then virtual images are rays that appear to, so let me highlight that. Virtual images are rays that appear to diverge, they come apart, and the image is upright, okay? So the virtual image that we talked about with the convex mirror, even though it's a lot smaller, it's still upright. Virtual mirror with the concave mirror, even the plant, even though the plant originally is smaller, it magnifies it. And that's it for chapter 13.1. Look forward to your homework assignments and other assignments. Thanks.